practical problems involving integral calculus. What we're going to have to do is look at some problems in a line of use of integrals to find the area under and between curves or between functions, and use of integrals to find the volume of solids and rotated solids. Okay. So, one thing, I put this on there for the other group because we will be using, you'll be needing for the next. If we take that curve there, where the line is a function of x, y is f of x, we can find the shaded area by using the integrals between the various limits. The limits here are marked a and b, c and d. So to find that area, we find the area of the function between the limits a and b, that's that bit. Between the limits of b and c is that bit there. And find the integral between the limits c and d, we find that bit there. So it's the area between the function and the x-axis, because that's what integration is. That's cut all the little bits added together. All right. When we do the numerical methods of integration, the approximation methods, you kind of get that a little bit better because you're doing approximation method and you're looking at the areas of the rectangles that you could estimate, or and using Simpson's rule around that. When we start to do that after the holiday, it'll become more apparent why the evaluating the integral is equal to the area underneath the function. So, determine the area between the curve y equals x cubed minus 2x squared minus 8x and the x-axis. Okay, so because that piece is underneath the x-axis, yeah. So you need to be careful, because let's say that was a function of power. Above the x-axis would be positive power, below it would be negative power, i.e. we're taking power from the source and then we're giving some back. So that has to be, if it's underneath, it has to be negative. All right? So, problem 1. How do we go about solving this? How do you think we might get our limits from that function? Because until we know the limits, we can't do a lot. How do we find, what do we need to look for? And if it's my could be a quadratic to find out that function. What I'm going to show you is you could use graphical methods to find the roots. Yep. You know, I'm finding I'm using this software or this system more and more to kind of check things that I do, because that's quite useful. Tell me, just read me out that function, please. Y is equal to x to the power 3 minus 2x squared minus 8x. And that's it, yeah? So this software, I can hide that and make the graph a bit bigger. I can pick out these points here. That doesn't look like what I've got in here. X squared minus x cubed minus 2x squared. This is, sorry, yeah. So we've got a portion here above the x-axis between the limits minus 2 and 0. And we've got a portion below the x-axis between the limits 0 and 4. Yeah. So they're the limits they're the limits we need to solve this problem. Minus 2 and 0, 0 and 4. Okay. So what we're saying there is this area is equal to the integral between none and minus 2 of the function take away, I'm going to have to go on the line underneath, the integral between none and 4 of the function. So we've got two definite integrals there. And this is where on the board it gets a bit messy because I ain't got much space. Let's extend the page a bit. So we're looking at area being equal to, nice big set of brackets, integral of x cubed is x to the 4 over 4, agreed? minus 2x cubed over 3 minus 4x squared. That one's between none and minus 2. We've got to take away brackets x to the 4 over 4 minus 2x cubed over 3 minus 4x squared between none and 4, because that's the portion that's underneath the x-axis. We've got to take it away. Yep. Everybody following so far? So that definite integral when x is equal to 0, that bit's going to be 0, is it not? As is that, as is that. It's not the whole thing equal to 0 when x is equal to 0. Yeah? Everyone agree? So we can write that bit as being minus 2 to the 4 over 4 minus 2 times minus 2 cubed over 3 minus 4 times minus 2 squared. We've already established and hang on, that bit's none, but that's none minus that lot, isn't it? Do you agree? Because you do upper bound, take away lower bound. So let me zero minus. And then this one is uh, 4 to the 4 over 4 minus 2 times 4 to the 3 over 3 minus 4 times 4 to the 2. Take away nothing. For completeness, that integral when x is nothing is equal to nothing. Probably best to evaluate the two halves here. We should get, if I've done everything right, the answer 49 1/3 square units. Yep. So we'll call that A1 And that's equal to, put the brackets in, 0, because that, if that's 0, the whole thing is 0, isn't it? Everyone agreed or not? Yeah? Minus, now we put that in when the limit is minus 2. So we've got minus 2 to the power of 4 over 4. Take away 2 times 4 cubed over 3. Have I done that right? Is that my poor writing? What I've done, isn't it? 2x 4 cubed over 3. Take away 4 times 4 squared.
Minus 2 brackets 4.
I'm not having a good day today, am I? Right. Minus 2 to the power of 4 over 4 is? Must be 16 over 4. Is that not 4? Minus 2 to the power of 4 is 16, isn't it? I think that bit's 4. Minus 2 to the 3 is minus 8. So that's minus 16 over 3. So it makes it plus 16 over 3, because that's minus 16 over 3 is plus 16 over 3. And then this bit is minus 2 squared is 4. 4 times 4 is 16. A function for velocity, so velocity of a vehicle during acceleration is defined by the function v is equal to 20 times 1 minus e to the power of minus t, where v is the velocity in meters per second, t is time in seconds. Determine the distance travelled by the vehicle in the first 2 seconds. So if we integrate that function, we're going back to a function for displacement. If we find the area under a displacement graph, we'll find the distance travelled. If we had travelled at 2 miles an hour for 2 hours, we'll have travelled 2 miles. 4 miles, sorry. 2 times 2. I can't even do bloody 2 times 2 now. Oh, I've had enough, right? So, what we're saying here is, if we integrate this and have the limits between 0 and 2, the first 2 seconds of travel, we would find the distance travelled in that time. So if we do this, and that's between 1 and 2. So, what I'm going to do here is use the online differential indicator to see what that says. Then we'll do it by hand and see whether we get the same answer, right? Because I'm starting to lose a little bit of the will to live here. Right, our function was 20 brackets 1 minus, what was it? E to the, I'll have to do minus x on here because I don't take t, I don't think, close brackets. And the limits we want are none and 2. Go. I'm going to look at the integral, I'm just going to look at the answer. 22.7. If we look at that graph, that's showing you the blue line is a graph of that function. And if you remember from science last year, what did that look like? What did that shape of graph look like? Think about the assignment, one part of the assignment. Capacitor charging, exponential rise to a limit. Yeah? So any car accelerating has got a limit that would accelerate to. So in this case, we got a vehicle that's got a maximum velocity of around 20, whatever the units are, meters per second. Yeah? So it can accelerate quite quickly, but then eventually how are we going to integrate that? What are we going to do to it? How can I simplify that? Let's write my t a little clearer. Or minus t. What can we do at 20? Yeah. So it's going to be 20 times the definite integral. So what does 1 turn into? t. And how do we do e to the ax? What's I in this? If that's in the form of e to the ax, what is a in this case? Yeah, I equals minus 1. So we'll put a minus in there for now. So it does not come out as 1 over a. Is that what the entry is in the table for e to the ax? Your table of integrals from this morning. One over a to the ex. So 1 over minus 1 is minus 1 in it. So that's minus. Therefore, we scrub that out and make it a plus e to the minus at between 2 and nothing. I hope this work out right. I really do. 20 times nothing plus e to the nothing minus 2 plus e to the minus 2. Now I cross my fingers and let you push the buttons. Now we go out the right way round. What answer do you get?